here is just the definition of STL. That STL stands for Standard Template Library, and it's a set of C++ template classes to provide common programming data structure. This just said in difficult English, I would say, but STL libraries are very important for competitive programming and for placements. So I'm giving just the basics so that you can, like, the one who are seeing this can go on with competitive programming in like different coding platforms and all. So the four parts of STL libraries are containers, iterators, functors, and algorithms. And so containers store data, iterators access data, and algorithms. These are just written over here. I will just explain it later. And yeah, STL consists of containers. Like a container in C++ is an object which is used to store like collections and of objects, and it's implemented as class templates. So containers consist of different things like vectors, or maybe a queue, stack, and many more. So why are we calling these containers? Because if you have a bit of knowledge in C programming, you will see to create a queue, we have to make a struct, and then we have to create a linked list, and we have to decide of our own that whether it is going to be a queue or stack. But in C++, we are having a predefined template so that we can directly implement a queue or a stack in it. And so what are iterators? Iterators are similar to pointers in C, so that we can iterate over the elements in a vector or in a queue or in a stack. So iterators just point to one of the elements in any of the containers. And algorithms is an ocean of algorithms are there in STL, and we will see how algorithms work in the next slides. And functor is just a function object, like it's simply an object of a class that provides at least one definition for operator. So in this webinar, we are not going to go in detail for functors because it takes a lot of time to understand functors, and it's sometimes get complex to understand. Um, so let's see what are vectors. So vectors are same as dynamic arrays with the ability to resize itself automatically when an element is inserted or deleted. Uh, so let's understand what are vectors. So we can initialize a vector like this. We will give a vector of the data type integer. The name of the vector is v. So if we want to insert any element in this vector, so let's take an integer like int x is equal to 2. So if we want to insert this value in the vector, we can simply write that v dot pushback x. So now v is having 2 in it. Now since v is dynamically allocated, so as many values as you can add, the size of the v will keep increasing. And there is also a resize function. So you can explicitly resize the size of the vector by using the resize function. And in C, we have the calloc or malloc functions for dynamically allocating it. But in C++, vector does it all of its own. Now stack. Stacks are a type of containers with a LIFO type of working. So let's understand what that means. So in stack, let's think of like a column of a thing. Like we can store data like this. So one data gets collected here. Let's say the value is 2. Then after that 3, and then 4. But when we are popping, we call this popping when we are taking out the elements from the stack. So we can only get the 4, like the last element which is inserted in the stack. So the last one which get inserted gets popped at first. So it's last in first out. So the last one which gets inserted gets popped out first. So that is stack. And in queue, it's just the opposite. Like if you are standing in a line, like 2 gets first, 3 second, 4 is third. So when you are popping an element, 2 moves out first, then 3, then 4. So this is a fair thing. Like this happens in real world, but we need stack sometimes. In JavaScript, stack is used, just for your information. Like in pairs is used to combine together two values that may be of different data types. Like pair is just like tuple we have in Python. Like we can store two different kinds of data type in a pair. In pair, we can declare it like this. So in P, we will be having pairs of int and string. So each pair will be having, let's take an example as 2 and then ABC. This kind of pairs. And we can also have 2 and 3, but 3 will be in the form of a string. Yeah. So there are many more different kind of specific containers. Like in Q, we are having DQ. So what is DQ? In DQ, we can just pop elements both from the front and from the end. But when we are inserting elements, it is always from the backside. So these are just the syntax. So in vector, you can see the data type and the vector name and all. So let's think of a bit complex. Like we can do nested containers. If we want to make a vector of pairs, let us declare a pair and let us think that it is a pair. Now we want a vector which is having pairs in it of the type P. So we can declare the vector like this. So the vector will be having elements and each element will be like P0, P1. So each of them will be a pair. So this can be nested like this. And in containers, I didn't write it here, but there are sets, maps. So both of them can also take any kind of data types here, but in case of unordered sets or unordered maps, we cannot use user defined data types as such. There is a restriction in that. Now let's take a question that given a vector which contains only 0, 1 and 2 as its elements, so the program should sort the vector in an increasing order, but the vector can only be transversed once during the entire running of the program. Like you cannot transverse it again. Like you are going from the first element to the last element, and again you are transversing from the second last, like from the second element to the last. So we cannot do that. We can only transverse it once, which means the time complexity is O of n. So let's first understand how we can do this, and then I will say the algorithm and the code too. So how can this work? Let's remove this. So I'm having a vector having only 0, 1 and 2. So let's think that the vector is like this 0, 1, 0, 1, 0, 2, 0. So this is the vector. What will be our desired result? It will be 0, 0, 0, 1 and 2. So we can do it like a simple sorting like insertion sort or any kind of sort, heap sort, but that becomes more complicated or maybe more time complexity. So let's think like that. At first, we make two pointers to the first element. One, let's say low, and the other one is mid, and the high pointer to the last element. Now, if we think like that, that this vector can be partitioned into three parts. Like one part will have only zeros, the other one, the middle part will have ones, and the third partition will have two. So how can we do that? If we think like this, that if the element we are pointing to is the ith element, maybe this one, anyone. So if we think that the ith element is 0, then it should go for low, like the low partition. So if it is 0, we will increase low and mid both.